In this video, I'm going to show you how to draw Lathe Project Number 1's engineering drawing. So open up SolidWorks and go to File, New. If you haven't created the solid model at this point, please go back and watch the video on how to create Lathe Project Number 1 solid model before creating the drawing. Now, once you have a solid model created, we're going to click on Drawing and OK. At this point, we're going to insert our title block. I have provided a title block for you up on Polylearn. If you wish to insert it in your own system to use it for all of your drawings, please follow the following steps. Go to Polylearn, download the drawing template by clicking on it. It should then be in your downloads. I'm going to go to the file manager here. Go ahead and find my downloads. Once you find it in your downloads, go ahead and right-click on the drawing template file, the .slddrt file. Go ahead and copy. Go back into SolidWorks, and in order to paste it into the templates, you hit Browse. You can right-click and paste. What this does is it puts a SLDDRT template file in your sheet formats in the SolidWorks folders. So now, when I go ahead and select IME 144 drawing template, it comes up with the template like you see in all of the lab manuals. If you don't see it showing up right here, you may have only show standard formats checked, and it will only show you the default SolidWorks templates. So if you unclick that, then you're able to select the IME 144 drawing template. At this point, we're ready to go ahead and insert model views if we would like, or I'm going to step aside and show you how to save the template with your name in the Drawn By section. So to do that, I'm going to click off Model View, and in order to get our name down here in the Drawn By section, we're going to right-click, we're going to Edit Sheet Format. What that does is it allows us to modify our template or our background sheet. At this point, I can go to my Annotations menu, and in order to insert text, I'm going to use the Note tool by clicking on the Note tool, bringing it down, zooming into the Drawn By, clicking my mouse button to place the box, and typing my name. You can hold down your mouse button to move the name into place. And when you're all done modifying your template, you can right-click, go back to Edit Sheet, and what you see on the screen is now a personalized template. In order to save it and have SolidWorks bring it up every single time with your name in it, you go File, Save Sheet Format, and you can save it as drawing template with your name or however you'd like to save it on your computer. So what I did there was I made a drawing template that always comes up with my name on it. Now, therefore, you don't forget to put your name on your homework. Okay, now we're ready to insert drawing views. In order to insert the drawing view, it's under the View Layout. There's two main ways to insert drawing views. There's Standard 3 View and Model View. I'm a bigger fan of Model View because I'm able to put the pictorial view in at the same time, and it seems like an easier method than going back and dragging a projected view off of a standard 3 view in order to create a pictorial view. So, in order to place drawing views onto the 2D drawing sheet, we're going to select Model View. We are then going to hit Browse in the left window here and find the solid model. So I'm going to select Lathe Project number 1 and press Open. What this does is it brings up a menu and allows you to select the different drawing views you'd like to place on the piece of paper. It allows you to select the line type that you'd like with the drawing views and your scale. So we'll start at the top. I want to create multiple views, so I'm going to select Create Multiple Views checkbox. This allows me then to select my front view as my main view. I'm able to select a right view and a left view, as well as the isometric pictorial view. So those 4 views will be placed on my sheet once I hit the check mark. Moving down a little bit, the display state is the types of lines that the CAD system will show for each drawing view. It will show full wireframe or visible, which does not contain hidden lines. It shows visible and hidden lines, or just visible lines. The other 2 are shaded models, which aren't really used on an engineering drawing, 2D. They might be used for other elements in the design process. So what we're going to select is visible and hidden lines, and we'll go ahead and go with the 1:1 sheet scale. If we look at our drawing back over here, we've got the front view, we've got the right view, the left view, and the pictorial view, all in a 1:1 scale, and you notice that we've got hidden lines. So moving back to SolidWorks, when I hit my check mark, it creates the drawing views for us. Now, there's a couple of issues. SolidWorks likes to put thread callouts on pictorial views, which is against the rules. So in order to delete those, we simply click on the thread callout, hit the delete key, and it gets rid of the thread callout. Next, pictorial views normally do not show hidden lines. It complicates them. So in order to remove the hidden lines from the pictorial view, we click on the view, it selects the view, and then we're able to select just visible lines for that view. Notice the visible lines button is also available up here at the top. So at this point, I'm going to go through and create all the different features you see on this engineering drawing. In fact, the first thing I do is I place my center lines and center marks. Notice the drawing in the manual is missing a center line. So we need to go ahead and revise this drawing and put it in the next revision of the manual, as well as put a center line on the drawings that you're going to turn in class. So we're going to go back to SolidWorks, and in order to insert center marks and center lines, I'm going to go ahead and delete the previous 2 center marks the CAD system put in automatically, and I'm going to go over to my annotations menu. In this annotations menu, I'm able to select center marks and center lines. When I click on center mark, it allows me to use the document defaults for the size. So if I do that and I click on the circle, you'll notice it makes the default size center mark, extending past the visible lines. So center marks are quite simple. You simply select the center mark tool, you then click on the edge where you want to place the center mark, and it places one for you. Now center lines, they're simple as well. In fact, we can click on center line. It does an auto view if you hit select view and auto view. That's one way to do it. Or let me click on the center line and delete it. I can hit center line again, and I can actually click 2 lines, and it'll put a center line in between the 2 lines. Now you're saying to yourself, that's not long enough. Well, it isn't. So I can actually click on the center line and drag it out to be the length that I want. Okay, Now that we've created the center lines and the center marks, it's time to start dimensioning. So I'm going to start off with the actual title block. Everything that we do for dimensioning is located in the annotations menu. In fact, if we need to put notes or text on our drawings, it's the note button, like we used to format our title block at the beginning of this tutorial. When I click on Note, I can simply bring the text box down here and type in the date. When I click outside the text box, it ends it, and it allows me to place a second text box with the same text. So what I end up doing is I place the text box and then just retype in the next piece of information I need to fit in my title block. So here, type in 6061 T6 aluminum. And then over here, we'll call it IME 144 Lathe project number 1. Now to end the text tool, we press Escape, and then we can actually use our mouse to line up the text how we would like to see it on our title block. Once the title block's fully filled out, we're going to go on to applying dimensions to our part. The first tool we're going to use is Smart Dimension. Smart Dimension allows me to dimension diameters and distances, and angles if we had any. So when I click on Smart Dimension, notice if I wanted to get this outside diameter right here, like you see this 0.925, I can go ahead and I can just click on that line and drag out. What that does is it sets a visible gap between the visible line and the extension line and places the diameter dimension. Now, looking at the drawing here, you'll see that we've got 3 decimal places for our precision. Moving back to the SolidWorks model, there's only 2. There's 2 ways to do this. I could go to my document properties, under my units, and I could select the amount of precision that I wanted. Or I can go ahead under Dimensions, go to 3, press OK, and now every dimension I place is a 3-place dimension. Let's say you didn't want to go ahead and make everything a 3-place dimension by default. You could simply click on the dimension. Right over here under the Tolerance and Precision, you can select the amount of precision you'd like on the dimension. Because remember, the amount of decimal places that you place on the dimension will directly affect the tolerance and the precision. Therefore, 0.93 is not enough precision for what we're going to be doing on the lathe in the lab. So we'll go down to 3 decimal places on this call out. Excellent. Notice my dimensions overlapping my center line. I simply drag my dimension off so this does not occur. So I'm going to go through and use Smart Dimension to dimension the different diameters, such as this diameter right here, the 725. I'm going to click on this line right here for the 625. And notice I'm not placing them very neatly at this point. I'm going to go through in a minute and place them very neatly after I create all the dimensions. Now, the 495 dimension here, the reference dimension for the major diameter of the thread, you cannot create that off this helix. Therefore, we have to dimension from that endpoint to that endpoint in order to get the 495 diameter. Now what I'm going to do, now that I've got my 3 measurements here, I'm going to drag them out like you see right here. And then, so I'm going to move the views around. In order to move the views around, you simply highlight the view, and then you hold your mouse button down and drag sideways. Remember, all the views have to stay aligned. That's rule number 3 from our projection concepts. So moving over, we're going to space out these dimensions. Notice I can make it smaller. Right there, the lead off. I can click on the 495, and in order to put parentheses around it, we're going to select Add Parentheses. That makes it a reference dimension that we actually don't measure. It's going to set up the diameter for us to use a die and cut the 1/2-13 thread. Excellent. Now we have all of the diameters set in the front view here. Remember, diameter measurements, when it's a piece of material, have to be performed in the side view. If it's a hole, then it's performed looking down into the hole. That's how we dimension it. So the next step is to select Hole Callout. We're going to dimension the 2 threaded holes in the part. So for the first one, we dimensioned the thread looking down into the thread. So we're going to click on the threaded hole, drag down, and place our dimension. Now notice, SolidWorks will go ahead and call out the tap drill size as well. We don't want to put the tap drill size on our drawing. We want to go ahead and only put the tap drills or the thread call out with the depth. So what I'm going to do is I'm going to go down to my dimension text, and I'm going to delete the top line by highlighting it and deleting it completely. What this does is it allows you to only specify the thread call out on the hole. We'll let the manufacturing engineer figure out that drill size. Moving on over, we're going to do that again with the hole call out button. Because we made the hole with the hole wizard, the hole call out button creates a thread call out or the hole call out for specific holes. Now, once I drag this dimension down, remember, in order to get rid of the top line, the tap drill's depth and size, we're going to highlight the top line in the dimension text and hit delete. This allows me just to place the thread call out like ANSI rules state. So now that the 2 threads are called out on the 2 holes, the diameters are all called out, let's finish up this drawing by selecting the different lengths here. So I'm going to click on Smart Dimension. I'm going to dimension from the back edge to this front edge, leaving a 1.750 dimension. Looking back at our drawing, it's 1.75. So I have to change the precision by directly clicking on the dimension and selecting 2 place decimal. The next dimension is the 2.5. It goes from the back edge to over here. In fact, do you notice how all these 3 dimensions are off the same baseline? Well, that's a datum dimension. I could go ahead and delete the dimension I just placed, and I want to show you baseline dimension. Baseline dimension allows you to first pick a datum surface to measure off of. Then you click edges that are the edge you'd like to measure to based off the first baseline measurement. When you're all done, you press escape and you're left with your datum dimensioning. Now remember, I have to go back and change the precision of these 2 measurements. They have a slightly different tolerance than the other 3 place dimensions. And that can be shown down here in the title block with the 2 place decimals plus or minus 10 thou, and the 3 place decimals plus or minus 5 thou. At this point, I'm going to step back and look at my drawing and compare it to this drawing. We're missing 2 things. Actually, 3. We're missing the note section in the top, we're missing the external thread callout, and the GD&T callout for circularity, a form tolerance. Oh, and a 4th, the chamfer. So, let's go back and place these items. Moving back to the drawing, we're going to start off with the thread callout. The thread callout is a note. It's a note that contains a leader. The leader is placed on the part by simply clicking on the edge of the part, and you drag down, click your mouse one more time to place the text box, and then type the thread callout in the text box. 1/2-13 UNC to A. A signifies external thread. Now in order to end the note tool, press Escape and drag your note so it appropriately lines up nice and neat with the other thread callouts. Now in order to place the chamfer dimension that we saw right over here, we're going to go underneath Smart Dimension and select Chamfer Dimension. With this tool, I pick the hypotenuse that I want to point the arrow to, and then an edge so it can calculate the angle off of. Let me show you that again by pressing Escape and selecting Chamfer Dimension. I select the hypotenuse and the angle to measure off of. And what I do is I drag the measurement up, and looking back at the drawing, I have to put a 2 by in front of the 50 thou and change the precision of the 50 thou. Because when I look at the drawing, I have a chamfer on this side and a chamfer on this side to start my external thread, hence the 2 by. So back to SolidWorks. Remember, the dimension text down here allows me to add text before or after the dimension that's been pulled from the solid model. So if I go ahead and type 2x space in front of the DIM in carats, it'll go ahead and add that 2 times symbol. Then directly above that, under the precision, I'm going to go ahead and pick 2 decimal places for the 50 thou chamfer. Remember, chamfers are mostly cosmetic, therefore they don't need a tight tolerance most of the time. So when I hit check mark, that placed my chamfer dimension. Now, up in the top left corner, we need to go ahead and place the notes for the drill's depth and the note to deburr all edges. So looking over here, it's simply a text box. So we're going to chamfer / deburr sharp edges. Then we're going to drill a certain depth for the 3/8/16 tap and a different depth for the 5/16/18 tap. So to place this note, remember it's the note tool. So when I click on note, I simply just click my text box up in the top left corner and I turn on caps locks. When I write notes, I just simply hit enter to come down to the next line, and I type 1 double space, I write chamfer / deburr all sharp edges. And then number 2 will be drill. I'm going to go ahead and pick a symbol over here in the notes box. I can hit add symbol. I can go to more symbols, and I know the depth is a hole symbol. So I go down here and I look for hole symbols and I pick depth. So we're going to drill a depth of 1.0 for the 3/8/16 UNC tap. Then we're going to drill, grab the note, depth 1.00 for the 5/16/18 UNC tap. Excellent. When you're all done with your notes, you can go ahead and press escape, and that'll go ahead and create the notes on your engineering drawing. Last but not least is to add some geometric dimensioning and tolerancing. So we need to go ahead and add the circularity form tolerance to this 925 diameter. So to do that, that's a very simple step. We're going to move on over here to the geometric tolerance tool. When I click on the geometric tolerance tool, I actually build my callout in this box, and then apply it to my drawing before pressing OK. So remember, there's 14 different characteristic symbols for GD&T. We're going to apply circularity. The tolerance for our circularity is 0.003. Notice it builds the feature control frame down in this box so you can see what your feature control frame looks like before placing it. Now, looking back at the drawing, we have circularity at 0.003 thou. So moving back, circularity at 0.003. We place that by zooming into the drawing and clicking the leader line on the surface we wish to apply the circularity callout on, and then pressing OK. Last but not least, we have to move it over in order to fit it in nice and neatly. Remember, your job when creating an engineering drawing is to make it nice and neat. So at this point, I'm going to press save. We should have saved often. And I'm going to save this document as an SLD-DRW document. Now, you should print this out and take it to class to turn it in. The issue is, if you don't have a printer attached to a computer or SolidWorks, you need to go ahead and still be able to print. To do that, we could simply go File, Save As, and I can select a PDF. It'll go ahead and save your drawing as a PDF, which then will allow you to go to any computer and print a PDF, or any copy machine here on campus. So looking now at my drawings, I just created Lathe Project number 1 drawing as well as Lathe Project number 1 PDF. There's the new PDF. There's the old PDF we went off of, missing the center line. Please don't forget to do that. Hopefully you learned how to create a simple drawing through this tutorial. If you have any questions, please don't hesitate to ask by stopping by office hours or sending me an email. Have a great day. I'll see you in the next tutorial.